All right.
You have any answer?
Okay. So let's see now. I think yesterday we talked about population sample, all that kind of stuff. We did that handout. We finished that handout, which is good. Yep. I like it. So I mean, you just got to get into section A1 and try it out. So the handout pretty much went over everything in section A1. So if the handout makes sense, you should be able to do the homework from section A1. Cool, I like it. Today we're going to get into. Let me before we get into the meat of what we're going to do today, let me do some stuff that's going to at first seem unrelated.
Okay.
All right, deep breath. Oh, weird shit coming our way. Okay.
Open mind.
Here's something that definitely seems like out of left field, but you guys remember this classic mistake students make about the difference between these two things.
Mm-hmm.
So one of them, they're definitely different answers. They are different answers. Which one is going to be positive for? Yeah, which one has two negatives, so they will cancel? The top one only has one negative. What does it have two of? Two twos. Do you guys see? What's order operations? What's good old please excuse my dumbass son say? What's that say?
Parentheses.
You would do parentheses? Okay, there's no parentheses, right? And here the parentheses don't mean, I mean, there's nothing to do inside.
Yeah.
There's no P in either one. Then the next thing you do is
Exponents.
exponents. And what is this? What is this negative right there? That's actually negative times 2 squared. That's really what that means. I want you guys to see that. So what is that? 4. So what's that? Negative 4. This is the negative of what that is. So that's negative 4. I like it. This one says you square negative 2. So of course you get positive. So the mistake people make all the time is it'll be this, but you put into the calculator this. And I've had people come up to me and say, Mr. Waller, you're full of shit. Look at this. Look what I just... And I'm like, well, you put it in the calculator wrong. The calculator's going to do what it can. Right? Poor little calculator. All right. Maybe. Okay, that's one thing that's going to... That idea is going to come up here in a little bit. Now here's something that's new. This is old. Here's something that's new, and I just want to focus on this idea by itself. Let's say I have some variable. And for us in statistics, so tell me, what's a variable? What does that mean? What's a variable mean? What is its purpose in life, besides to screw up the problems?
It holds the place of an unknown number.
I like it. So it can take on how many values?
1. Or, well,
Yeah, it can take on a lot. At one time, it can only be one thing, but it can take on a lot of values. How are we doing so far?
Yeah.
So let me ask you this. If my question to people was, how old are you? Then my variable can have what values? It would have the values of
Each individual.
everybody's age. Are you guys with me so far?
Mm-hmm.
I like it. So, for example, if my variable was, how old are you? So in statistics, the variable is a question. And then the values of the variable are the answers. That's the data. We call it the data. I like it. So if I ask people how old they are, and somebody said 21, 19, 38, 47. Let's say I only had 4 people I talked to. Now this symbol I'm about to write is the Greek letter S. Anybody know what the Greek letter S looks like? Mm-hmm. If you're interested in a fraternity or sorority at all, or have seen any movies with them in it, you know this symbol. Or you've seen it. Good old freaky E, right? E with the sharp elbows, whatever the hell. That's the Greek letter sigma. It's actually the capital Greek letter sigma. So it's the letter S, basically. And we use it to mean sum. The sum of. And of course, sum means adding. I love this. Remember that. Sum means add. So if I said this, the way to read this is the sum of the x's. All right, well, how would you do that? Now that we know how to read that sentence, that question, what would it be? What would the sum of the x's be in this case?
Add all four of
Just
them.
add these up.
Yeah.
So we got 40 there, 78, 115, 78, 125. Yeah. 110, yep, 125. Are you guys cool with what's happening? So, I mean, has anybody ever seen this symbol used in this way?
No.
Do you understand that that's what math is? Math is taking a huge sentence and then making a symbol out of it. So, for example, real quick example of what I just said. By the way, so this will be 125. Real quick example of what I just said. What is this? 7. I love it. Because you know what the sentence is that goes with this symbol. The sentence that goes with the symbol is, what does it take 2 of to multiply to be the inside? Good Lord, math people, we don't want to write all that shit every time I want to ask that question, so we make a symbol out of it. So what's this thing say? What do you get when you add up all of these? That's what it says. So once you realize that's what a lot of these symbols in math are, you're not going to feel so freaked out when you look at the next page and it's all these kind of weird-ass symbols. You just got to know what they mean. What do they represent? What question do they represent? All right, let me throw a couple of things at you then. Here we go. So sum of z. Oh shit. All right. I like.
You got an X.
That's where? This?
What is that?
That's a z.
Oh,
Yeah.
I guess.
I mean, that's for you. There's a z. There. Not really the same. I know my s's look like 5s, right? I know my 3s look like c's sometimes. But my s's and my z's do not look the same. Please don't go that far. This first one should be easy, right? What do you get here for this first one? 20, because you just add up all the z's. You didn't add these up because it didn't say sum of y's. I like it. So this is just 20. Now what does this say to do? What do you have to do first? What's order operations say you must do first?
Add up the y.
Yeah, do the inside of the parentheses. So what's the sum of the y's?
17.
17. And then you
Times
square it. So you get sum of y is 17. And what do you get when you square 17?
289.
280. All right, how are we doing so far? A little good, a little bit good. All right, let me play around with those z's over there for a second here. So, how would you do this then? Do you see how that's different from that last question? And this relates to the very first thing I talked about. No parentheses. I like it. So this one said you had to sum up the y's and then square them. This one says square the z's and then add them up. All right, let me stop there for a second. Do you see the difference there? Right, this said square what? Square the sum of the y's. This says sum up what? Sum up the z squares. So let me write the z's. You guys look so excited. I love it. Here's the z's. Now why do you think, see what I made? I made another column because what am I going to put next to that? What do I have to add up?
It's squared.
I have to add up the z squares. So I got to make the z squares first before I can add them up. Okay. So make the z-square. So
9.
9,
1.
1, 1,
16,
16,
121.
121. I love it. And now to do what this says, I just add up the z-squares.
148.
Yeah, 148, I like it. So the sum of z-squared is 148. All right, I like it a lot. All right, one last one of these. So this is what math is all about. You learn what a symbol represents, you learn how it acts. And once you learn how it acts, you can do a lot of problems. So for example, I'll give you another one here. Give you a bunch of X's here. Let's just make it 2, 3, 3, 7, sure. And let's say I ask you, what is the sum of x minus 1 squared? Ooh, I like it. All right. You can do this, you can do it. I know you can. I'm pushing you a little bit. But think about what you have to create first before you can add them up. So try to do that. Okay, here we go. So the math involved here. The math is not what's difficult. It's just getting used to what the symbol means and the order to do things in. What do I need to make a list of? Like here, what did it say? It said to add those up. I had to make a list of z-squares before I could add them up. So I need to make a list of x minus 1 squared. So maybe I can make a list of x minus 1s. Right? Let's make a list of x minus 1s. And then I can make a list of x minus 1 squared. I mean, do you see how you just be nice to yourself? Just construct what you need for this problem. It says, add up all these. Do I have these yet? No, I don't. Okay. Well, let me take one away first. And then next to it, I can just square it. That'll be a lot easier. So what goes here? 1. So let me make sure everybody understands. When I'm at this row, the value of x is 2. So then when I see x minus 1, I'm going to put a 2 in. That's the basic stuff of algebra, right? So now you can see we're listing all the possible values of x, and then we're doing shit with it. So this is just algebra, just organized in a little bit different way. So what goes here?
3.
2. 2. 6. Now what goes here?
1.
Yes, 1 squared is 1.
4.
4. 4.
36.
36. All right, let me stop there for a second, you guys. So this column is x minus 1, and this column says square these. Well, these are right here. So I just square them. And now it's easy to do it this once. It says those, add them up. Why can I do it now? Because now I got those. I can see them. I can add them up now. So what do you get when you add them up? 45. Okay, I like it. I like it a lot. Okay. And of course, one reason math people, we like to consolidate how we talk about things, we don't like to write big sentences, is so they can have a nice, concise little equation that does a lot of shit for me. It's a very quick way of telling people how to do a process. I have this little equation that does that. So let's get into... all right, well, let me ask you this just directly. Let's do some old stuff. How do you find the average? By the way, just because I can't leave anything alone, we are now going to call this the mean. How do I find the average of a group of numbers? So if I give you a group, of numbers. It doesn't matter, Jeff. You can do it, man. All right, give me a second. Just tell me in English how you find the average of a group of numbers. What would you do? Add them all up and divide it by,
How many?
in this case, 5. In general, how many there are, right? So how many numbers are there? 5. So we're going to use, so in English, how do you find the average? In English, it's add them all up, then divide by the number of data points. Let me just get technical there for a second. So again, this could be answers to my question about how old are some people at a bus stop or something. Right? So these are data points. These are numbers, but they're data points. They're answers to some question. Right? And this is what you all would agree. Some version of this is how you find the average. But now we have a symbol for add all of these things up. Right? What's the symbol for add all these things up? Yeah, the sum. So I want to sum. So in Mathish, the mean would be the sum of all the variables, values, all the data outputs, divided by the number of data points. And what letter do you think I want to use for the number of data points?
N.
I love it. You guys are like, is he giving us a clue or is he having a little something? A little medical moment. That is the formula for the mean written. It's just written. It doesn't change what the mean is. It's the same old thing, but that's how it looks like in the math language. This is what it is in English. This is what it is in Mathish. Right? I like it. And the symbol we use for the sample mean. Bless you. Something happened? Is X bar. We read that as X bar.
Oh my God.
Let me let that sink in.
So what's the difference between that and the one to the right?
This is the equation for it.
Oh.
So if I said find X bar, that means find the mean, because that's what that means. That's the sample mean. That's the average of the group of numbers I got from a sample. So that is what is known as the sample mean. And what's the mean the name for? What we think of as average. Now, to be honest, what we think of as average is only one kind of average. So in statistics, we're a little more specific. It's the mean that we mean. Okay, and I love it. I know somebody out there is like, you math people having to make everything so complicated. Before today, I could find an average, and now I don't even know if I can do it anymore with all that shit you just threw at me. But this is what it looks like. This is what the formula looks like. My God, if you never want to use this formula, don't. I understand. But what's important is the symbol and what it means, because it's going to show up in another formula later that you don't know anything about. So what do I get when I do that? Of course, let's just do that real quick. So the mean is the sum of x over n. What's the sum of the x's here?
84. 84.
84. Divided by
5.
5.
Is 16.8.
Okay. Woo! I like it. So the idea of average didn't change. I just showed you what the formula looks like in math. Don't let this trip you up. You know what this symbol means? So this is the quick way of saying this. They say the same thing. It is a different language, so it takes a little getting used to. Do they make a distinction between... No. Good. I like that. That works. Yay! Okay, good. Keep it on. All right. Now, what's the mean kind of tell you about a set of data? What would you say the mean tells me about this set of data? What's it trying to tell me? When you take an average, you're trying to figure out what. So if I told you the average grade, are you doing right?
It's like the mid-level where most people.
All right, I like the way you said this. So the mid-level, so the in some way it's finding the middle, right? Is it really the exact middle? No. Let me show you an example. So let's say I go to a company. I want to start working at a company, and I say, hey, man, how much money could I expect to make? Right? And he says, okay, well, Fred makes $35,000, Bill makes $38,000, Sally makes $42,000, and the big boss man, and he makes $650,000. Right? This little company. You guys with me? Unfortunately, it's pretty much the truth. But, hey, is there a shot? Jeff, politics outside the classroom. So if I told somebody, if they said, what can I expect to make? And I told them the average, on the surface it seems like that would be reasonable. But take a minute and figure out the average of this.
91.25.
Yeah, so if you add them all up, divided by how many there are, you get who what?
191.25.
191.25. So $191,250. You guys with me? Because that's in thousands, right? Now, if I told this dude, oh yeah, you could expect to make $191,250. Is that being honest? No. So we're about to use, so this is one way to measure the center. It's not always the best way. The mean is one way to try to get the center of the data. It's not always the best way. So whenever they talk about salaries or home prices, for example, you don't say the average home price in San Diego to somebody. You don't tell them the average. Has anybody ever heard or paid attention to or read articles, paid attention when they're talking about home prices? The word they use is not average. The word they use is median. The median home price, the median salary. What the hell's the median? What's the median in the road? It's the middle. Oh, so the median of a data set is the number that's actually right in the middle. So how many numbers are there here? This is going to be a little bit evil.
4.
So real quick, little side example. Number in the exact middle. Why is the mean like here? Do you see what I mean? Isn't the mean like right here? Why is it not in the middle? Because this stupid number pulls it up, right? Skews it. Perfect. So the median doesn't give a shit about the values. It just says what number's in the middle. So real quick example, that's a little bit easier than this data set. What number is right in the middle here?
7.
So, and notice, what is it about my data that makes that valid? Say again?
Is it because it's not an even amount of numbers?
Yes, so it makes it easy to find the middle, right? I can find the middle finger on my hand because there's 5 fingers, and there is a finger in the middle.
But they're all the same family.
But why? So if I did the same set of data and I said this, does that suddenly make the median 1? That's the same data, right? But the median ain't 1 because the median only makes sense when they are
In order.
in order. I love it. They got to be in order, or else you can just make it whatever the hell you want it to be. Okay, maybe. So again, everything we've done so far is attempting to find the middle of a set of data. So the mean is one way, but it's affected by what we call outliers. I always think about Children of the Corn. Have you ever seen it? Outlander. You ever seen it? Outlander. No? Okay. Huh? Scary movie, exactly. You don't like those? Not that one. Okay. Right there. All right. So that's no good. So 7 is the middle. So what's wrong? What's kind of wrong with me asking you what the median is for this set of data? How many numbers are there? 4. Is there any finger in the middle of 4 fingers?
No.
Which one? I'm going to grow another one. I am Groot. No. So here's what's kind of cool. There is no single finger that's in the middle of these 4 fingers, but these 2 are sort of in the middle. So if I average these two, that's the middle of the middle. Holy shit, you can't get more middle than that. So the two here, so these two numbers are in the middle. But the median has to be one number. So you take the average of these two. So if there's an odd number, it's easy. Just get the middle. If there's an even number, you got to average the two in the middle. So then what do you get for the median for this one? 40. Yeah, the average of those two is 40. I love it. So, and if you put 40 here, isn't 40 right in the middle?
Yeah.
It's got 2 below it and 2 above it. The symbol we use for median is like the symbol for mean, but after a good or a rough night, depending. So here's it looks like this. Yeah. Right, his little hat got all squished up.
So the median is that.
That's the median, exactly. With the tilde, right? That's what you call it, the little tilde dude on there. He's all fancified. I love it. So it makes more sense to use the median to describe data if there are outliers in your data. Because would the median change if I made this 65?
Yeah.
Would the median change?
No, because
The median is still 40. It's still in the, right? Do you guys see what I'm saying? So the median is not affected by the values. The median just cares about how many there are and what's the middle of that, right? The mean, if I made that 65, the mean would change a lot, wouldn't it? The mean would change a lot. It would be a lot lower than 191. So I use the median to describe stuff like home prices in La Jolla. My God. Walking around La Jolla, I just go walk around like, I might be invited into one of these places someday. But I'm not going to. Well, you never know, Jeff. Maybe you'll play the lottery, even though you know statistics. Okay. Blah, 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 blah. Oh, okay. So far we got the mean. We've got the median. There's actually 2 more ways to find a center of data. Yeah, I think I heard somebody just now say something. The next one's really nice. The next one is the mode. Right? Always makes me want some apple pie with ice cream pie a la mode. The mode is the number that occurs the most. So that's the easiest center number in the world. The number that occurs the most. If no number occurs the most, then there's no mode. So let's do some examples. 1, 2, 3. What's the mode?
none.
No mode. Right? No mode for you. Come back 1 year. By the way, there's no symbol for mode. It's just the word mode. Poor little mode. What about if I had 1, 2, 2, 3? What's the mode? That's crazy. What about if I had 1, 2, 2, 3, 3?
Then you add.
Would you average them?
Nope. Bimodal. 2 modes.
Oh yeah. Bond.
2 and 3. And then you can have, not surprisingly, maybe you can have trimodal. And then after that, we're like, no, screw it. There ain't no mode if there's more than that. Some books will say you can have polymodal, like polynomial. Remember that? Polymodal? Screw that shit. If it's trying to cluster in more than 3 places, you ain't clustering nowhere. That's too much. Mode is the only measure of center that can handle non-numerical data. How are we doing? Right? So let me show you an example of that. Let's say I go out to the parking lot and I see 47 Fords, 32 Chevys, and I see 3 BMWs. Right? What's the mode? Force. There you go. See, so mode is the only one of these that works with data that's not numerical. And I can ask people questions that don't have a number answer. But I can still calculate a mode for those, which answer occurred the most. And that's useful to know. right? Like if I go around saying what news do you want? How do you get your news? I'm curious what's the way most people get their news. I want the mode of those answers. I like it. So we got mean, median, mode. So one more weird little dude. But I first want to talk about this last weird little dude. I want to first talk about something related. So let's say I have this data up there. Right? And I ask you, what's your gut tell you the range of that data is?
Between 4 and 17.
Okay, I like it. And now we're going to make a single number out of that. So it's going to tell me how wide the data set is. So it goes from 4 to 17. So how wide is that?
13.
17 minus 4, 13. So what's the formula for the range? High minus low. I like it. Let me let that sink in. So I know we're doing a lot today, but every single little thing we're doing is pretty simple. You just got to get used to them. And it's possible some of you guys have talked a little bit of statistics before. Some algebra courses are including statistics nowadays. This is really basic statistical analysis, right? It's one of the first things we want to do. So when you guys did these, a lot of you guys were calculating the average because that just makes sense. That's a good first thing to calculate as you analyze some data. So you guys just naturally did that. I didn't say to do that. I love that happened. Yes?
Quick question. I can't remember. Do the numbers have to be in order to do the range or no?
Well, it's high minus low. So it doesn't matter if they're in order. You just got to get the highest one and get the lowest one. Yeah, that's all that matters. I like it. So that's not a measure of center. Are you with me? That's a measure of how spread out the data is. Does that make sense? The reason I want to talk about this first, before I introduce the last way of thinking about center, is because the last way of thinking about center is called the mid-range. Now it's really unfortunate, just is the way it happens, that this is a minus here. Because what does it feel like mid-range means? It's the number that's in the middle of the range. I mean, you can't beat that stuff, right? Mid-range, the middle of the range. So how do you find the number between two numbers? You take the average. So notice the mid-range formula is going to be high plus freaking low divided by 2. And that just trips people up. Because the range is high minus low, which makes sense. It tells me how far it goes.
And then divided by.
Yeah, and the mid-range is the average, so it's got to be plus. So a lot of people, when they do this, they put a minus there, and I'm like, oh, shit. Just remember, mid-range is an average. You add to get averages, right? So what would the mid-range be here? It would be 17 plus 4 divided by 2.
19.
Uh-oh.
Right.
So you did a calculator mistake.
Yeah.
This has to happen in your calculator, right?
Divided by
No?
is 10.5.
Yes. This is 21 divided by 2. What's 20 divided by 2?
10.
10. And then one half more would be 10 and a half. Yeah. I like it. Okay. Ooh, I like it. That's all right. So let me summarize here what we know, and then I'm going to unleash you on a handout as I always do. So what do we know? We know the mean looks like that. The median. The median is just the number in the middle, right? And I think let me see if they give you this little formula before yeah, okay, they give you this little formula. What was the median? So 1, 2, 3, 4, 5 data points. Which data point was the median if these are in order? Which data point?
That one.
This one, which is the 1, 2, third one, right?
1, 2, 3.
1, 2, third. I like it, right? So now let me see if you guys get this before. And the book gives you this formula also. 5 cut in half is 2.5. That doesn't make sense. It's not the 2.5 number, right? So the formula is n plus 1 divided by 2. If I do 5 plus 1, that's 6. Divided by 2 is the third one. So how do I find the median? Where is it? N plus 1 divided by 2. So real quick, if I have 4 numbers, what's 4 plus 1
5.
divided by 2?
2.5.
2.5. So 2.5. That tells you the average, the 2 and the second and third, the one that's in the middle of the second and third. So if you have an even number of numbers, it's going to come out to something and a half. That means the number in the middle of those two. If you have an odd number, it's going to come out to one of the numbers. It's awesome. So you can use this or not. It's up to you. Right? If I have a big list of data, I want to use this. If I don't, I just freaking find the middle in a few different ways. I like it. And then we have mode, which is the most, the one that occurs the most. And then we finally have this mid-range thing we just did. Sure. Alright, so let me unleash you guys. Students unleashed. It'd be really smart to group up with some other people and divvy up some of the work on the sheets. I'm going to run back and get my, well, how many of you guys need to borrow a calculator? Several people. Okay. I'm going to run and get my calculators for you. Turn this poor little dude off.